Seventh one is what? Hmm, what's that? 4, 5, 7. Yeah. A baseball diamond is a square 90 feet on one side. Okay, okay, this is given. Okay, so this is the question. Okay, so this is the first base. Third base. So 90 feet. A player runs from the first base, okay, to second base at a rate of 16 feet per second. At what rate is the player's distance from the third base decreasing when the player is at 30 feet from the first base? Okay. Third base, okay. That's what I think. So let's say you have moved X here. So how far are you from the third base? Tell me. Let's call 90 feet as L. If you have moved X, what is the length remaining? L minus X. So what is the distance of the person from the third base? Can we find it out? Using Pythagoras, we can find, no? So Z square equals to, and it's done. We are over. So we can we differentiate this with respect to time, both sides? Differentiating both sides with respect to time. So if you differentiate both sides with time, what you will get? Tell me. Use the chain rule.
2z dz by dt.
Excellent. On the RHS, the first term will be 0, I'm sure, because it is constant. So what is the differentiation of second term? See, if you have confusion, you can do the differentiation separately. So what is the differentiation of second term? Is that the difficulty which you faced? Shreya, you haven't submitted the solution. So you all are supposed to submit the solution. So if you're not submitting, then it is a kind of violation to the fact that you haven't solved. So I'll presume that you haven't solved anything. And after 2-3 warning, everyone will be stopped from the lecture. If you fail to submit twice, you won't be able to attend lecture. So what is the differentiation of the third part?
2 into L minus X.
That's it. We have to go further. So this is the, if you're writing like this, see, you will add d by dt of L minus x whole square. Now this we can rewrite as I'm writing here only, d by dl minus x, because that's common. Then dl minus x by dx, that's common. Then dx by dt. These are the steps. Do you realize this? So what you will get is actually twice of L minus x into minus 1 into dx by dt, which is okay, fine. This is given to us. So the 2z dz by dt will be equals to minus 2 L minus x dx by dt. 2 gets cancelled out. And what we are looking for? Dz by dt. So the answer is minus L minus x upon z. And dx by dt is given to us, if you remember. It is 16 feet per second, right? Because this is the American book, so you are getting such kind of a British book basically. So they use the FPS system. You know FPS system?
Yes.
Foot pound second. So no need to worry. You can convert it into meter per second and then can think of 90 feet as 90 meter. You can solve like that way. That's totally okay. And the question is, they're asking the answer at a instant when the player is 30 feet from the first base. So X is given or known to us. So to get this answer completely, we need to do one more manipulation. And what is that? At X equals to 30 feet, we need to find Z first. So Z will be 90 square plus 90 minus 30, which is 60 square. 9 square and 6 square is how much? 81 and 36. Is it a good value or bad value? How much is this? 617. 117. That's really bad value. Anyway, so the answer will become minus 60 upon 10 root 117 into 16. So 16 into 6 is how much? Can you check the answer? I think answers will be given to you.
Sir, in the answer key, only the answers of the odd questions were given.
So this is question 7, no? This is odd.
So, but for the even questions, we don't know.
Yeah, that's right. But even it's not given, so you have to ask. Okay. So what was the question? The rate of thing, no? The question was. Okay, there are multiple questions. Okay, again. D part. The D part is. Yeah, that's the answer. Minus 96 by root 117 is the right answer. Okay. I hope this is clear.
Yes,
Yeah.
sir.
Next doubt, tell me.
Eleven.
Suppose a raindrop is a perfect sphere. Assume that through condensation, the raindrop accumulates moisture at a constant rate proportional to its surface area. Show that its radius increases at a constant. Okay. So imagine we have a raindrop. And this raindrop will have some radius. Now through condensation, what happens? The raindrop will kind of coalesce. There is a word called coalesce. Coalesce. So coalesce means it's like a kind of collapse, but coalesce means basically when you bring two droplets closer to each other, they will assimilate and eventually convert into a single bigger drop, and they will remain spherical. So the shape will again becomes spherical. Okay. So what they are saying is that the raindrop accumulates moisture, which means the drop, at a rate proportional to its surface area. Okay. So when you accumulate the droplets, you increase the volume, right? Isn't it?
Yes.
So eventually you will have a bigger volume. Let's say a lot of raindrops has already collapsed, and volume will grow at what rate? So volume will grow at a rate which is proportional to its surface area, which is so dV by dt is 4 pi r square. That is given to us. When we remove the proportional with some constant, we write k. So we write dV by dt equals to k into 4 pi r square. Show that the radius increases at a constant rate. So we have to prove that the dr by dt is constant. Now we know that volume of a sphere is how much? 4 by 3 pi r cube. So what is the dV by dt, guys? Tell me. If I differentiate, what I'll get?
4 by 3 pi into 3r square dr by dt.
Which is 4 pi r square dr by dt.
Yes.
And we have seen from the equation 1 that this must equals to k times 4 pi r square. So the 4 pi r square gets cancelled. So what you get is a dr by dt is dr by dt is some constant, isn't it?
Yes.
Which means the rate of growth of the radius is growing, but it is growing constantly. And this is what we have to prove.
Yes.
So I'll say hence proved. Okay. Next, please. See, the whole idea is, can we write the relationship and can we differentiate it? So we have to make a guess about the relationship. We have to search for the mathematical relation. Once you are able to search the relation, try to express with the help of some variables. And once you're ready with the expression, differentiate with time and correlate the things. So this is a typical behavior of solving any question of maxima, minima, or rate measure. All are similar in its nature or signature. And that's why, see, why kinematics is difficult, because when you solve erodive of kinematics in erodive, it is more about differentiation, less about kinematics. And that is why we are doing the right kind of practice. We are trying to go more into mathematics, so that when we face such question, we should be comfortable to an extent that, okay, you can do it on your own without much help of teacher. So I want you guys to be mathematically very strong. I mean, even if it takes for me to 1 month extra to teach you more maths, I'm okay. At the end of the mathematics, you should be equipped with all the ideas of mathematics, how to do the calculation part. Physics is pretty easy. I mean, there is nothing in physics. It is all about mathematics. So how to convert your ideas into mathematical notation, mathematical formula, and how to manipulate it. That is the skill that we develop through these exercise. So the purpose is quite obvious. We are developing the underlying mathematics to solve the challenging problems. Any other doubt, guys, so far?
So question 17.
Very good. So this is again a very nice problem. A point moves on a curve. So there is some curve. See, no matter what equation they write on a paper, when I say curve, you can always imagine a picture of some sort of curvy line on a two-dimensional world. So I don't know what is this, but this must be some curve in the line. I mean, XY plane. Okay, but here we have this line or this graph is a very famous one, and you can write as 3x squared by 12 minus y squared by 12 equals to 1, and this is x squared by 4. And what this represents is called this kind of graph in a format x squared by a square minus y square b square equals to 1 is called hyperbola. If I change the minus into plus, it becomes ellipse. So from ellipse and hyperbola, it's like if you have an ellipse and if you cut into two halves, and if you reverse if you rotate it otherwise, like the opposite direction, so it's a two half ellipse cut like this. So when we have ellipse in this shape, we called it parabola. Okay. So basically, this graph is a parabola, and it's good to know. Even if you don't know, it doesn't matter, because we are doing it mathematically. So we should get the answer at any rate. So that its y coordinate increases at the constant rate of 6 meters per second. So what is given to you? Can you express what is given to you? Can you convert this language into mathematical relation? Its y coordinate increases at a constant rate of 6 meters per second. How to express it? Tell me.
So we have dy by dt.
Very good. And that is given as 6 meters per second. So do you guys realize this part? The language and mathematics? So
Yes,
when you read a line, the only skill we need to understand is how can we express the line into some mathematical relation. So it is correct that this is equivalent of writing dy by dt equals to 6. Okay. Okay. So when I say the acceleration due to gravity is 9.8 meter per second square, what does it mean actually? Can you guess? How to express it in a mathematical term? So when I say gravity is 9.8 meter per second square, which means the rate of change of velocity that the gravity is able to create is 9.8 meter per second. That is the meaning actually. So rate of change is everywhere. When I say a particle is moving with a velocity of 5 meter per second, then I'm saying either if I know its direction, but at least I can say it is moving at a rate. It means the distance, that rate of change of distance is 5 meter per second. So every sentence in physics can be expressed in some mathematical term, and that is the only skill I want you guys to acquire as much as possible. Okay, this part is clear, hopefully. The first part, dy by dt is 6 meter per second. Okay.
Yes, sir.
The next part is at what rate the x coordinate is changing. That's very simple. See, someone is giving you y, asking you x, so you have the constant given to you already. You're not supposed to bother about the constant because x and y having some relation which is given to you. The only job is to differentiate, isn't it? And because one of them is given to you, you can easily find the other one. Yes or no?
Yes, sir. I'll do it now.
Yeah. So now you can just differentiate and you should get the answer. So, Prashansha, Rugved, tell me guys. Shreya, are you able to understand this part?
Yes, sir.
So it's not difficult, isn't it? I mean, just you need to read and acquaint yourself with the language and the meaning of language in a mathematical terminology. So math is called the language of physics. So it is like a poem written in a symbolic notation. Try to read the poem and try to express it. You will enjoy then physics. Next question.
So I
Siddhant?
had a doubt in the eighth question whether the radius is changing or the height.
Just a moment. Eighth question. Let V be the volume and S be the total surface area for solid right circular cylinder that is 5 feet high and has a radius r feet. Find dV by ds when r is 3. So, but they're asking the volume, change of volume with total surface area, dV by ds, right? What they're asking? Find the V is the
dV
volume
by
and
ds.
S. Yeah. So the rule is simple. Siddhant, you got the answer for 8th? I
So
think
I took rate as the variable and I got the answer as 15 by 11. But I just assumed that the rate was changing.
okay, fine. First of all, what is
Yes,
the
sir. I
volume
got
of
it.
what is the volume of a right circular cone?
Pi r square h.
That is for cylinder
By 3.
by 3. 1/3 of the cylinder, right? So the way of remembering is okay, it is 1/3 of cylinder. Okay, so it is 1 by 3 pi r square h. So this is the volume. Okay. What is the surface total surface area?
Pi r l plus pi r squared.
Correct. Very good. So you can see clearly we have too many variables. We have h, we have r, and now we have L also. So L is basically slant length. So to make it a single variable function, I'll use a trick. And the trick is simple. I'll choose the semi-vertical angle of the cone as theta. What are the benefit of this? Everything we can express only in terms of L and theta, right? So we can add H as L cos theta. We can add R as L sin theta, isn't it? So with this trick, we can actually make it quite a simple relation. So we can add 1 by pi R you can write as L sin theta. H is L cos theta. Is this correct, guys? Tell me yes or no. So this will become pi L cube, I think so, by 3 into sin square theta into cos theta. Similarly, what about area? Pi R L plus pi R square, which is like a pi L square. We can take common. Sin theta plus sin square theta. I hope this is the idea we are getting. Okay. And now we can differentiate. Okay, so because theta is a common function, at the end of the goal, our goal is to find dv by dA. But the trick is because we have been able to express into a single variable theta, so we can write as dv by d theta upon dA by, because we can find this value and we can find this value separately, and then we can relate. So if you differentiate the numerator, let's do the differentiation of each term separately. Okay. Okay, I got it. So here the constant is height, h is fixed, only r is changing. Okay, okay. H is constant, so we can go with this relation directly. So this is not required, but anyway, this is also good. It will be helpful later on in some other question. Let me solve it again. So here the h is constant, h is 5, which is kind of constant value. So only r is the variable. So we must express answer in terms of single variable, which is r. And even h is present, that's totally okay because h is constant. So volume is 1 by 3. We can take phi h common. And r square is variable. And the area, or you can say s, is how much? Pi r L plus pi r square. So that's fine. I can either substitute L here, or you can differentiate separately. So pi r, which will be slightly difficult to do. You can do it separately in a better way. So let's differentiate both with respect to r, because r is the only variable. So dv by dr is how much? Now we have r as a common variable because everything else is constant. So dv by dr will give you how much? Pi h by 3 common. And what is the differentiation of r square with respect to dr?
2r.
2r. And similarly, if I try to find ds by dr, it is okay. I'll choose this one, pi, and I'll use the product rule, which is L into d by dr of r plus r into dl by dr plus pi into 2r. So this will become, and you can find L equals to how much? L square is h square plus r square. So basically 2L dl by dr will be 0 plus 2r. So dl by dr is r by l, and therefore from 1 and 2 we can write ds by dr equals to how much? Pi l plus r by, so dl by dr is r by l, so I can substitute. So we have L square plus R square by L, and we can substitute The L is how much? H square plus R square. So we got both values, and now you can take the ratio of the two. So we got dV by dr is and the ds by dr we got pi and r is given 3 feet, right? R is given 3. So let's find this one. H is 5, R is 3. So at that instant, it is 10 pi. This will be how much? Pi. H is 5. So 5 square plus 2 into 3 square. So that is the problem with foreign authors. They really don't bother about the good values. We can attest 10 pi by 25 plus 18 is how much? I hope this is clear.
Yes, sir.
Yes, Siddhant. Can you check your answer?
Sir, I don't have it. I don't have the answers for the even questions.
No, you have solved. So what was your answer?
Sir, I solved for a cylinder. No, you solved it for a cone.
Okay, this is cylinder cone.
Cylinder.
Sir, I also
Ah,
did for cylinder only.
oh, that's why it is so complex. But you said cone, na? Which question was you said? Did I made a mistake in reading the question?
Sir, I thought you were trying a different example. I'm sure.
Okay, maybe. Okay, that's why. Okay, that's why it become very complex. It's a easy question, and I just made a mess of it. Okay, I thought it's a right circular cone. Okay, anyway, but that's good. Okay, you saw something. Nevertheless, this is simple. So pi square h is fine, and s is 2 pi r square plus 2 pi r h, right? And h being constant, we can differentiate. So dv by dr equals to 2 pi rh. You can see it goes 2r into pi h. And ds by dr is how much?
So here, how do you know that H should be constant or R should be constant?
It is given that it's a solid cylinder, right cylinder, that is 5 feet high and has radius r feet. Okay. Or maybe so I thought, okay, in that way, okay, because the height is fixed in a way, they have mentioned 5 only, and the radius is r, which means it is variable. And then they're asking find dv by ds when r is 3. So if r would have been constant, they would have mentioned the value in the beginning. but they mentioned the value of height as 5. So ds for dr is how much? 4 pi r plus 2 pi h. So d by dr is how much? 2 pi r h. So it is coming out to be 15 by 11. Okay,
Yes, sir. I also got 15 by 11.
that's
But I
correct.
took R as constant.
Yes, sir.
Okay, take h as constant. That's okay. That's fine. Next question. Tell me. Next.
So 9.
No. At what rate the area of a triangle formed by the ladder, ground, and wall? We have done this, no?
Sir, in this question, I was confused with the diagram. Like they have written and wall in example 3.
Just a minute. Okay, example 3 belongs to book. Okay, I got it. Let me send you. You can see the diagram now.
Yes, sir. So this question is doable.
Yeah, this is doable. We have done this question. So I will not solve. Next. So tell me the next question. If you rest, you have to attempt. That's good. Attempt and finish. Or it's a very small chapter. Just 27 questions. So how many you attempted, Siddhant?
Sir, all.
All. Very good. Rugved, you attempted how many total?
Sir, I attended till second page.
Okay, that is up to 16, 17, 18, 18. So let's say you are climbing a mountain, a mathematical mountain. Okay. And the mountain is in the shape of a parabola. The equation of the parabola is written as ax square. So you can clearly see. So if you choose any point, so the direction of your velocity at that instant will be in this direction along the mountain, isn't it? So let's say you're cycling, maybe you are some world famous cyclist climbing the mountain. If you're a mountaineering cyclist or whatever, your velocity at any instant will be in the direction of what? In the direction of the mountain itself, isn't it? So in mathematical terms, can we say the direction will be always along the tangent? So when you move along any curve, the direction is always along the tangent to the curve, isn't it?
Yes, sir.
That's logical because that is the way you will move for sure. So that is the track you're following it. So in time dt, because the track is curved, in time dt we say that okay, you travel ds. This is a very small part ds, and because ds is really small, this part can be treated as a straight line, yes or no? Can we treat as a straight line?
Yes.
So now you're going to learn something really deep. So elementary part we can write as ds, and so if I take a projection on the x-axis and similarly projection on the y-axis. So we call this part as dx, and this part as dy. Understood? So if one part is ds, one part is dy, dx and dy, how to relate these two, these three quantities? Can we use Pythagoras? Can we use Pythagoras?
Yes,
Yes
sir.
or no? So if you use Pythagoras, we can write ds square equals to dx square plus dy square. Now the way of writing is dx square we can write is, we can take dx square common, it will become 1 plus dy by dx whole square. And therefore, if you want to take a ds value, you have to take the square root of this entire term. So dx will come outside because it's a square. So what we're left with is okay. So now knowing this formula, will give you something really important. Just write it. So what we're getting is ds equals to 1 plus the first derivative square into dx. Okay. So what is the ds by dt? Now because we are dividing by dt both sides, the answer is pretty much simple. It is simply dx by dt. So what is ds by dt representing? Your speed along the mountain, isn't it? This is the velocity in the or along the direction of mountain. Understood? And dx by dt is basically at what rate you are going away from it. So this is the x. So we know this is the dx by dt. I hope this is clear. So the v represents d. So the v always represents ds by dt. So when you are moving along a track, along a curved line, the v is ds by dt. The ds is the elementary distance which you travel along the curve. But the vx, the dx by dt represents vx, the x component of velocity. Because if you look at the velocity vector, it is like this, and this is the vx vector, and this is the vy. So basically, vx is nothing but the rate of change of x coordinate, and vy is nothing but the rate of change of y coordinate, and we have a nice name given to it as a vx, vy. And because the y graph was given to you, because if graph is given, it means you can differentiate. So dy by dx is how much? Tell me, guys. dy by dx is how much?
2ax.
2ax.
So can we substitute there? So we can add ds by dt. So 1 implies ds by dt is how much? 1 plus 2ax whole square into so finally the speed of the biker is 1 plus 2ax. So it depends on where you are. So we can write vx like this. If you want to write vy, let's say somehow one fine day you want to write vy. It is again not difficult, because if we differentiate this function, we can write dy by dt equals to 2ax dx by dt. So vy is basically equals to 2ax vx. And how much is vx, guys? Here we have got the answer for vx. So finally we have vy as well. So vy is how much? 2a 2a vx. So let's say if you have a motorcycle and you're moving with constant speed of the motorcycle, so v is constant, but everything will change. The vx will change, vy will change. So that's confusing. So we have 2ax into v upon so you can see that if the motorcycle velocity is constant, depending on the x coordinate, we can find the y coordinate. Okay. So do you understood? I mean, realize this question, like how to attempt, how to think about something like
Yes,
this.
sir.
So this is called the distance, length. I mean, this is called the length of the curve. It's called length of curve. And this is the way of writing the length of curve. Okay. This formula is also used for finding the total length of curve. So let's say if you have any curve like this, if you want to see, we can find the x and y easily, but what about the length of the curve? If I want to add all values, if I want to find this measurement. So for that, the formula is simple. If y is given as a function of x, the length of curve. Okay, we'll study in the integration. We write as 1 plus and we have to add all such values because this is for dx part. If I the dx part will have this much length, so that to find the net value we do the integration, which I'll teach you very soon, and we get the answer as something like this. So again, we are going to use this some part in future, not now. So imagine a situation. If I make a groove, so why I'm putting so much effort? I could have achieved this with this itself. And there is a rod actually, a rod like this. And there are two screw attached. So this screw is like a lock. So the groove and this vertical rod is like a in a way locked because of this the nut or the screw. So what will happen as the rod will move forward, the screw will go away or will come close. What will happen? So as the rod will move towards the right, what do we expect? The screw
The distance
separation will
between the screws will increase.
correct. So let's say this is given as V. So the rod is moving with velocity v, which is constant. And the equation of this groove is, let's keep it so this is the very standard parabola equation. So at what rate the separation between the nut or the screw will grow? At what rate? Separation between what we call nut, no? Or hinges. Now, when you write an equation like this, the y represents the distance from the origin, not from the bottom. This is the y. This is called x. So, what is the separation between them? So, we can add separation equals to
2y.
2y. So, what we are looking for is ds by dt, which means we are looking for twice of dy by dt. Now, this is the language to the formula. And we can find dy by dt because we know dx by dt, isn't it? Can we? What is given to us? V is constant given. So mathematically, what is given to us? Tell me, guys. What V represents?
Dx by dt.
So dx by dt is given to us equals to how much? The value V, isn't it? So dx by dt is given to you. Dy by dt we are looking for, and we have a constant here which connects the two. I hope you know the further method to get the answer, right? So tell me the separation, tell me what is the answer. Question is clear to all of you?
So what is A here?
A is some constant, ignore it.
So what do we have to find here?
ds by dt.
So is it 4AV by Y?
Yeah, something like that. So y square is 4ax. So if you differentiate, what will get? 2y dy by dt equals to 4a dx by dt, which is given to us, right? So dy by dt, how much we got? 2a v by y, right? So ds by dt will be how much? Twice of this value, which is twice of. So ds by dt, you can leave like this. That's totally okay. And or if you want, you can write in terms of x. So y is 2 under root ax. So it is like twice under root of a by x. So given the x, you can find the ds by dt at any instant. So these kind of group problems are also very famous in kinematics. Okay. I hope this is clear. Any doubt in this, guys? Tell me.
No, sir, no.
So I will share some more numerical problems on rate measure so that you can practice at home. Let me show you something interesting. So imagine we have a conical shaped vessel with open top. So as you start pouring some water, some liquid, the water or the liquid level will start rising inside, isn't it? So if I choose this as the origin, and if I choose the height, the axis of cone as the y, the biggest radius, let's call it capital R, and the total height, let's call it a capital H. What is given to us? Try to understand carefully. The rate at which the liquid is poured is given to us as constant. So dV by dt is given as R. So the rate at which we are pouring the water or the liquid is constant and is equals to R. Here R itself is a rate. So if you are getting confused, you can call it K. This is not radius, but this is constant. So we know that water level will start rising. So question is, at what rate the level of water will rise inside? At any instant, let's say when the height is y, what is the dy by dt? What is dy by dt? That is the next question. So try to find it out, not very difficult. What is given to you? What is given to you is the volume flow rate is given to us. At what rate the liquid is being poured is given to us. So how much volume we are adding per second. And we are supposed to find at what rate the water level will rise. So dy by dt is how much? I think I can give you 5 minutes for this. Tell me the answer in 5 minutes. Find the answer. Of course, you can take any variable y. Okay, go ahead and tell me the answer. So long time back, I shared the differentiation problem with the theory notes also. How many of you went through those theory? Anyone?
Yes, sir, I went through.
Very good. No one else, right? Prasansa, did you went through? I mean, did you go through this theory part?
No, sir.
Why? Were you busy?
Or I forgot to go through it.
You forgot. Very good. Rugved, did you went? I mean, did you go through this?
I went through till second exercise.
Try to read the entire thing because that's a beautiful theory given. You won't get it a lot of mathematical theory. So in maths, normally you get formula and questions. But it is always good to learn math through the theory part because people don't do, and that's why they struggle. And they complain that math is hard. Math cannot be hard. It is pure a poem. And physics is combination of math and physics. Concepts plus mathematical skill is called physics. So what you do is in physics, you learn the concept. Concepts are mostly definitions. And with the help, or you can say aid of maths, you try to manipulate and express. That's why someone good with physics is actually good with maths, at least in some part of it, the calculus part. You can say the algebra or the other part of mathematics is uh, less relevant to application part of physics. But still, I would say that if you're reading maths, try to read through the book, through the theory. And only the foreign authors give the theory. I mean, if you read any Indian author, they don't know how to give theory. Okay. So if possible, by the Calculus by Thomas. It's a really nice self-learning book. You can keep on reading as and when you have time. But keep some books at home. Similarly, for algebra, keep Hall and Knight. For Trigo, keep S.L. Loney. For coordinate geometry, keep S.K. Goel is a nice book. Just keep some books at home. Not because you need to read everything. It's because when you want to read, you should have something to read. Or at least download from online. So if you are good with, if you're comfortable with reading ebooks, then it's free of cost nowadays. Everything is free. So let's say if you're not getting some deep insight in some of the topic of maths, start reading theory, you will get the deep insight. Maths is like that. You have to read theory, then do the derivation, you will be good with maths automatically. And in particularly calculus, I will suggest that to read a lot of theory of calculus. Because there are two parts of calculus. One is the definition part, which is quite difficult for most of the students. Other is the numerical part, which is like quite easy. So people go through or get through the first term and second part easily. First part is always challenging for most of us because there is no relevant literature available which we can read and understand. Problem is that. So reading habit should be always there, no matter how many coaching institutes you go to, how many teachers you study with. at the end, what really scale a person from ordinary to extraordinary is the reading habit. Okay. So I always suggest to make a habit of reading. Always read something, physics, chemistry, math, something. Always you should have some book to read. Read some theory. It will change you. It will transform you. Okay. Then this part. So the first step is what? First step is to find the volume as a function of y. Now we know the what is the volume of a cone?
1 by
1 by
3
3
pi
pi
r
r
square.
square.
So the volume of the water is how much? We want only water volume, right? So we're current 1 by 3 pi. We don't know the radius of this, this part. We need this radius, isn't it? Because we are adding the volume of the water, not the entire cone. Because this will change what? The water volume or the cone volume. Whatever you are adding to the cone will change the volume of the conical shaped liquid, isn't it? This part. Hello, hello, hello.
Yes.
So what is the volume? What we should write here? 1 by 3 pi. Pi. Am I audible, guys? The volume is equal to how much? 1 by 3 pi. Come on, come on, come on.
So smaller r square
R square.
h
What is h here?
y
Y.
delta.
Only y. That's it. You got the volume in terms of r and y. Is r constant or variable?
Variable.
Is y constant or variable?
Variable.
So when you get a function, because volume is a function of r and y. So when you get a function with more than one variable, what we try to achieve? We try to relate those two because we want at the end just one variable. That is the thought process. The moment I get two variables, I will try to eliminate one of them. So now the next step of thinking is how you are going to relate r, which is small r, y, which is small y, in terms of other constant given to you, capital R and capital H. I mean, can we make other utilization of these variables to relate each other? And if yes, what we can use? Tell me, guys, how to link a small r with y?
So here can we use trigonometry?
Yeah, of course you can use trigonometry. If you want, you can choose
So
some
like
angle.
we can assume an angle and
Yeah,
we can relate r and y by tan.
very good. So tan theta is how much? But in a bigger triangle, you can see every conical problem. See, when the moment we come across a cone, this relation is obvious choice to proceed with. So the moment you write tan theta is r by y, in a bigger triangle, you can see this we can also write as capital R by H. So basically, tan theta was given to us without your, explicitly being mentioned in the problem. It was given to us, isn't it? The purpose of giving capital R and H was to give you tan theta. So tan theta is r by y, and that is also equals to r by h. So what is r now? Finally, r is So with the help of the geometrical constraint, like the shape of a body itself is a constraint. So this is well-defined shape, so it will serve as the constraint, and therefore there must be some relation between the variables. We got the relation. What will be the next step? The volume we should relate in terms of y itself, isn't it?
Yes, sir.
So what we need to eliminate,
Small r.
and we have the well-defined formula of r in terms of y. Can we do it so? Can we do it now,
Yes,
guys?
sir.
Once you do it, can you differentiate both sides with time? Of course you can do. So do the differentiation and tell me what is dy by dt coming to. Tell me the answer. Everyone, please. If you have not understood, raise your hand. If you have understood, solve it.
Done, sir.
So dv by dt turns out to be how much? Tell me. What are you getting, Siddhant?
1/3 pi. 1/3 pi r square
Why
upon
r?
h square into 3y square.
Okay, you need to say capital R square.
Actually, dv by dt is equal to pi capital R square upon capital H square into y square into dy by dt.
Just,
The 3 gets cancelled.
yeah, correct. Okay, let me just rewrite here. So now if I substitute here, the new v we can write as 1/3 pi. So the v turns out to be pi r square 3h square into y cube, isn't it? So now if you differentiate, what will get?
Yes, so the constant which is pi r square upon 3h square, and y cube, when you differentiate, you get 3y square dy by dt.
Very good. So that's why the 3 gets cancelled. So dy by dt and dv by dt is given as k. Kh square upon. And what you can realize that as y will grow in value, the dy by dt will not grow much. And that's logical. Because as you go very high, your open area will become so large that the dy by dt will not appear much. Do you realize this?
Yes, sir.
And that is what exactly happens with the ponds and the river. So when we have a large pond, even a small rainfall will not let you see the change of level very significantly. because it is such a wide open area that water will start filling it, but it will not rise very fast because the Y is really. So imagine we have some sort of you dig a small pit of some random shape like this conical shape, and then the water starts filling in the rainy season. In the beginning, it will fill very fast. It will rise very fast because, but once the area becomes really large, the change will become slow and slow. And slow. So now we need some extra heavy rainfall to fill. I hope this is clear. So cone problems are very peculiar problems. So similar to cone, we do have a problem called the spherical bowl problem or the ball problem. Spherical okay. So imagine we have a spherically shaped object. So this is the leaking bowl. So we have some small hole at the bottom. Its radius is r. At any instant, the liquid level is here. And water is leaking out of it. So if I call this is y, how you're going to find the volume? So the question may be, what is dy by dt? This is going to be difficult. Okay, I'll teach you something new thing, but anyway, you can think about it. The water is leaking out of this. So maybe generally we put a leaking what we should call leaking vase above the shivling, right? If someone has seen the shivling in temple, they have the leaking vase, okay, and the water drip at constant rate roughly, isn't it? So as the water will drip, the level of the water will decrease in the vessel, right? So I'm looking for what is the dy by dt as the water has already dripped till the depth of y. What is the dy by dt at that instant? Assuming the liquid which is coming out is constant. think about it, then I'll tell you how to answer this.
Sir, in this case, we can't use trigger also, no?
Right. In this case,
Because
we can't
theta will
use
become
anything.
variable.
We can't use anything. We have to use something more deep, and that is the idea of elementary behavior. So we'll talk about something called elementary behavior. This behavior we will explore more in the chapter of integration, but right now, just we'll look for a small part, elementary behavior. What exactly is elementary behavior? So have you seen potato? Anyone? Rugved, have you seen potato?
Yes.
And how you will define the shape? A random shape or well-defined ellipsoidal shape, round shape? What do you call?
Random.
Random shape. So everyone will agree with this. I mean, with Rugved that most of the potatoes are random shape.
Yes, sir.
Have you seen wafers? And looking at a wafer, can we guess the shape of the potato? Frankly,
Yes, sir,
no.
we can.
No, frankly, we can't mostly. You don't know whether that has come from the oval shape, round shape, conical shape potato. Because when I am creating the wafer, I am taking a slice of it. So can we really differentiate between the slices? If I give you 3 slices from the 3 different shape, can you guess and tell me which slice belongs to which potato?
No,
And
sir.
I will make sure that the cross section I'm cutting is same in all 3 intentionally. Can we guess now?
No, sir.
No, so
So the elementary behavior says that when we cut something really thin, as thin as that's called DT or DTH and D thin, it is so thin that all are equivalent. So if I have cut every slice with same cross-sectional area and their thickness is really small, it's called dx as of now. That's easy for us to understand. Then every slice, no matter where you choose from which potato, every slice is something either like this or maybe slightly tapered, something like this. But as the thickness will decrease, the trapezium will transform into what?
Rectangle.
Rectangle, exactly. So for very thin slice, it is a very good approximation to always consider as a rectangle, as a rectangle, as a, and that is the beauty of the thin slice. The thin slice, the thickness will be like a, so it is not a rectangle, but we call it cylinder, thin cylinder. Do you realize the cylinder? This is your very, very thin elementary cylinder, right? Isn't it? Can we call this as elementary cylinder? Tell me guys, yes or no?
Yes.
And the thickness is dx. Dx means it is something which you cannot imagine. It is so thin. Understood? So what is the volume of cylinder? We all know. So imagine a cylinder of thickness dx. I'm just exaggerating the diagram. And the base area is A. What is the volume? Volume equals to, we can call the volume as dV. So volume equals to how much?
pi r square h.
So what is pi r square? The area of the base. Is it?
Ah.
So it is A dx. Yes or no?
Yes, sir.
How many of you are able to realize this, that it is at the end it's a dx? Everyone?
Yes.
You have doubt? Okay, no. So the whole idea is, in time dt, if I take a elementary time dt, if I give really small interval, the height will diminish by very small. How much? In time dt, the y will grow by what value? Dy, can we say? So in time dt, the water level will go down by dy value. Can we assume like this? Yes or no?
Yes.
So what we are losing? We are losing a volume equivalent of that thin wafer-like cylinder. Aren't we losing this volume? So how much volume we lost? Can you guess? How much volume we lost in time dt?
A dy.
Very good. So from time t to time t plus dt, we lost that much volume, and that volume has come out of the hole itself, isn't it? So you can see dv that we are losing is how much? A dy. So dv by dt equals to a dy by dt. Can be right? Yes or no?
Yes, sir.
And we're done. So we were looking for what? Because this is given to us, na, k. So what is dy by dt?
K by A.
Now can you find the surface area of this wafer? Can you find the area part at least? So area will be k by pi r square, isn't it?
Yes, sir.
But r is not given. This r is not given to us. Can you calculate the r in terms of y? So using basic Pythagoras, you can get the answer. How? Anyone who has guessed the answer? How to do this? Draw a triangle like this. This is radius, isn't it? The center to the periphery is radius, capital R. Am I right? Y is given to us. We want to answer in terms of y. So what is r square? See, we got the answer. So can we substitute here? And see, we're done. How
So
fast is
if
this?
we
Yes.
take root,
Oh, no, no,
it is
no,
R
no.
square.
Yeah, sorry, my bad. So what you can realize that the elementary way of solving is so effective, especially in case of volume and all, that it will take away the burden of finding the equation and differentiating. So if you have understood this part, I'll show you how you can solve this part in one line. So as you add the water, the height will increase, isn't it? In time dt, it will increase by dy. Yes or no? As you pour water, the height will grow, yes or no?
Yes, sir.
So you're adding a wafer thin cylinder to the existing volume, yes or no? You are adding wafer thin cylinder in time dt, yes or no? So how
Yes.
much volume you're adding? Can you tell me the volume you have added in time dt? What is the volume added?
A dy.
A dy. So what is A, by the way? Isn't it pi r square? The small r. Am I right? Am I right, guys? Yes or no?
Yes, sir.
Yes, sir.
So I got the answer d by dt is pi r square will remain as such. Dy by dt, and we have already done this calculation about r. So the k equals to pi and r is ry by capital H whole square and we were looking for dy by dt. See, we got the same answer. Much faster speed. Like how much time it took to solve? Almost no time. We could have done this mentally. Can you imagine the power of element? Elementary volumes by nature are cylinders, and therefore it is the most convenient thing to write. And we have the same answer. Do you realize this? We have the same answer. Can you see the answer? Is it same or different? Siddhant, tell me.
It's the same.
Rugved, is it same or different?
Same.
So are you guys able to realize the power of elementary? Or are you finding it really difficult? I mean, not able to realize. The
Sir,
elementary
understood.
says that elementary means we add something or we remove something as a thin layer. And the layers are so thin, it is beyond our imagination. And because of the thinnest possible volume, everything which is like a thin will be having nice cylindrical shape. Or if not cylindrical, it will have the finite cross-section, and the volume we write as cross-section area into height if the cross-section remains same. So what is the volume of cylinder? If you remember, volume of cylinder is pi r square h. What a pi r square represents?
Area.
Cross-section area. And what you can realize that cross-section area is same throughout, isn't it? So what you're writing is you're writing volume of a cylinder is area of the base into height, where area of the base is constant. In case of cone, what was the issue? The base area is changing, yes or no? So as the cone will change the height as you go from the vertex to the base, you can constantly see the cross-section area will keep on increasing, yes or no? For any cone, if you go from vertex to the base, what do you think? The area of cross-section will grow in value or remain constant?
Increase.
Increases. But if I cut a thin slice of it, then if I walk across the height of the slice, do we expect a change of area or can we consider as constant? I think this part is not clear. What I'm saying is, slice is also some volume, no? So slice will have the beginning and slice will have the end. So if you walk across the beginning of the slice to the end of the slice, do you expect any change of cross-section area? Yes or no?
No.
No. Why? Because it's a thin. So is it matching the idea of cylinder? Yes or no? Is it matching the idea of cylinder, guys? Tell me yes or no. When cross-section is not changing, can we treat as a cylinder?
Yes.
Yes, sir.
And if we can treat as a cylinder, can we write its volume with ease? What is the volume we have to write? Area of the base into height. Once again, for elementary cylinder, for elementary slice in any shape, the volume having the fixed definition without any ambiguity, and that is what? Every elementary thin object will have uniform cross section. Is this clear? Yes or no?
Yes, sir.
So how many of you like pizza? No one.
So
Everyone.
me.
And the rest of you, Rugved, you don't like? Rugved? Huh? All left. Yes, Prashant, you tell me meanwhile. Do you like pizza? Yes or no?
No, sir, not that much.
So what do you like in food? What do you like to eat more?
Sir, anything Chinese or Japanese?
Okay, so sushi, right?
Yes, sir.
Okay, and Rugved?
Yes, sir. Pizza is okay.
Okay. So today we are going to learn how to buy a pizza mathematically. So technically, most of the pizza will look like a cylindrical thin slice, right? Roughly cylinder, not exactly, but roughly cylinder. So what is the volume of cylinder? Pi r square h, isn't it?
Yes.
So if I choose a radius as z and the height as a, what is the volume?
Pi z square a.
Pi z square a. Okay, now you know why the name is pizza. Pi means pi. It is pi z square a. It's basically volume of the cylinder. That's a very famous name. So how many of you were knowing this idea? This is pi square h. Anyone? Were you aware of this fact? Yes or no? Siddhant, were you knowing this? Anyone who would I mean, you were knowing this fact that it is volume of cylinder?
So never thought of it.
So when you go and buy a pizza, they give the size also in inches, maybe 7 inches, 9 inches, and whatever. And they give price also X, Y. I don't remember the price list and the size dimension which they offer, the small, medium, and large. Okay. So what should decide the price? If you go by the toppings, so if the topping is too much, the area will matter. So bigger pizza will have. So imagine if you have R and 2R and 3R. The surface area is, see, the H is same, roughly same for small, medium, and large. So no matter which pizza we choose, the thickness A is roughly same. So they play with the idea of Z, the radius. So what you can count is how to compare the two radius. We count not the radius, we count the area. Okay. So if you write the area of a piece of radius r, pi square, but for 2R it is, and for 3R. So technically, if the price offered for this is 100, this is 500, this is, let's say, 800. So which offer is the most interesting offer? The best offer is A is same for all. Even if I write the volume, it's same. So which offer is the best offer? Can you guess? Small, medium, or large?
Sir, large.
Large. Because if you count the price per unit area, it is really small. So it is 800 by 9 factor. So this is like 100. This is like 125. But this is less than 100. Okay. So by looking at the dimension, you can just check the price, check the dimension, find the area, and find the price per unit area. Okay. So what is the price for unit area? And the one with least unit area price is the best offer. So now you know how exactly to buy a pizza. Anyway, that's a beautiful story of cylinder and pizza, just to make it interesting. So I hope you remember that thin slices are having cylindrical shape, and the volume is pi r square h, which is pi r square h. So pizza math is over. So now we are going to start a new topic. This is one small topic which I haven't mentioned, but it is like, it's a rarely used. So if whenever it is come to, I mean, it will come to picture, I'll explain the theory at that instant. So we'll go for something called integration. So differentiation is like a, understanding the difference of the two. So the reverse or the inverse process is integration, which is the summation of the two elementaries together. So when we add elementary, let's say if I want to find the volume of a potato, what I'll do? I'll take one slice, we'll find the volume. We'll take another slice, we'll find the volume. And probably every slice will have different radius. So we can find the average radius, and we can use something average. Roughly, we can find the volume of potato. The best way is to take the potato, take a vessel, brim the level of the vessel with water, insert potato, see how much water is coming out. You can find the volume. That's another way. So integration is basically a way of saying addition. You add something. So what you add? So you add the thin slices of something. So when you add thin slices of something, what you get is the full shape or the full volume or the full area, and that process is called integration. So we'll come to the idea of integration through graphical picture itself, and then we'll come to the numerical solving. So we'll start with the definite first. So what we mean by integration? So let me start with the geometrical meaning first. Geometrical meaning of integration. Geometrical meaning of integration. Okay. Every function which we write to y equals to fx mathematically represents a graph, isn't it? Which means for every x there is some y. So graph is basically locus of point, right? If you remember what is graph, it is locus of point which moves or which varies as per the relation, and the relation is called function here. So every y equals to fx mathematically it means some graph. Okay. So now imagine if I draw a graph like this. Imagine if I draw a line which is parallel to x-axis. And now I would like to find the area that this line and the x-axis encloses. So if I drop a perpendicular from this line and this line, the end of the line. So it is touching at, let's say, x, and this is x plus delta x. And this height is constant, it's maintained as y naught. So this area which we enclose beneath the line, or to say graph, how much is this area? Can you tell me the area? How much is this area, guys? Tell me. This area is equal to how much?
Delta x into
Into
y naught
Y
minus
naught.
x.
very good. Sorry. So area we know the answer is y naught into delta x, right? So you are able to find the area because it is a rectangle, isn't it? So do you know the formula for any other area which is not rectangle?
It's a circle, triangle.
No, we only know only one formula. It is rectangle. By definition, only rectangle, or I would say square formula, is known to us. So let me tell you what is area exactly. Area is a concept. It's a very deep concept. Try to understand what is area. Imagine if I take a square boxes of 1 unit each. So the moment I add 2 square box, I don't know the length, so I can call this is 1 unit. This is 1 unit, so this will become 2 unit. So what is the meaning of area of this rectangle? We call 2 square units. Do you realize this, what I'm saying? See, we are not trying to find the area. What we're trying to say is we're trying to say some numbers. We are saying this area is equivalent of 2 square units. Do you realize this? If I add more units, more square here, so what you can say now? How many square units is the new area?
6 square units.
See, you're saying 6. If you bring 6 square shaped, you can 6 unit square. I can say 6 square. Yeah, 6 square. We bring 6 square. of unit size. The idea is we write area as something square unit. We don't know the, still I don't have the idea what is this. What I'm saying is, if I create a box of length 1 meter each, or 1 unit each, then this region can be covered with 6 such boxes. Can cover the land or the area which you are showing here, which you are showing here. See, we have no idea of area. I'm just saying it. I'm saying, okay, see, this is the given land, piece of land, and I want to cover with some tiles. So what you do is you bring a tile of unit length, 1 unit width. So you take a square tile and you repeat the square tile as many times as possible till you get it completely covered. So what you say? That this area is 6 or 10 or whatever number square units, which means if you bring so many tiles and if you try to put it here, you can cover it. That is the meaning of it. So do you realize the meaning of what? Area of a rectangle. Are we really measuring the area? Can we measure the area? The answer is no. We compare the area. So area is a process of comparison, and it is some sort of axiom in maths actually. So area of a rectangle is called the axiom in mathematics, and using that axiom we try to find other area or other complex area. The interesting fact is, no matter how complex a shape look like, the area method only uses the idea of rectangle. We don't have any other formula in maths actually. So every triangle is actually half of rectangle, isn't it? So no matter what shape you draw, at the end of the day, this is some sort of, let's say if I draw something like this, look at this. You can draw something random. 1, 2, or maybe I can stop it here, or I can go here. No matter what shape you choose, if you realize this is collection of many rectangles. I hope you can realize this easily. So this area is half of this rectangle. Do you realize this? This area is half of this rectangle, correct?
Yes, sir.
This area is half of this rectangle, and this area is this entire rectangle. So every shape which we draw will have collection of rectangles. So even a triangle is a fraction of a rectangle, and there is no way of finding the area of triangle. I mean, I cannot bring something square in shape and fit it. So rather what we do, we double the area and then we half it at the end of this. It's a really deep thing. Okay, I mean, if you try to ponder upon this, you will get surprised that we are not able to calculate area so far. We are able to compare area, and therefore we use a unit, and what we will say is square unit. Okay. So square unit is a way of writing the, like, how many times of this value I put it to get the given area covered. That's the meaning of the number of times. So that is the axiom, that if I have a rectangle of a length L, so let's say if L is, this part is L unit and this part is B unit. So how many square unit we need to cover it? The answer is we need LB unit into unit, which is like a LB is the number, the count square unit. Understood? Are you getting the idea what I'm saying? So the LB is representing the count of the square unit, which can cover this part. That is the whole idea of area. The unit square which we are creating. So we have the definition of length. So I'm creating a shape of in the shape of a square with length of 1 and 1. Okay. But we have no idea what is inside that 1 and 1. We have no idea what is the area exactly. When area is some sort of idea that you compare against something standard. So this is the square unit is called the standard, and we make it the multiple of that square unit to get the entire area. Okay. And we have only one area in mass. I mean, there is no second area, just rectangle. And every kind of area, no matter how complex it appear to your brain, can be derived from the rectangle. Understood? Are you getting the idea what I'm saying? See, we don't know. If I just look at this square, we don't know what is this. What is this area? I mean, how to express this part? We don't know actually. We just call it. You are saying it. What you're saying? You're saying that this is a region covered by this square tile. It is the name of the tile, square tile. This one unit square tile can cover this much region. So if I give you any amount of region, you will tell me how many multiple of this tile I need to cover it, and that is called area of rectangle. So the length and width will give you the idea that how many times. So when you say L into B, you actually tell me the times. Are you clear with this idea what I'm saying?
Yes, sir.
Okay. So how many area you know? The answer is just one.
Only one.
In fact, you will be surprised to know that there is no second area. And the even more interesting fact is that every area I will show you the derivation through the rectangle. I mean, that's always true. So yes, we can find the area. Now we are good to go with idea of area. So if I plot a graph, and this is the most, you can say the most powerful concept that you are learning. And I can assure you that 99.999% IITian, those who go to IIT, even they don't know this. So don't worry about if you, it is a strange topic. In fact, those who have done the research in mathematics, they only know this hard fact about the area. So it's an axiom actually. No one knows that area is an axiom. It's not something which you have measured at all, and no one can actually. So we express actually. So now if I draw a line which begins from the origin, then the shadow or the area beneath this curve, see, we always talk about the area below the curve up to x-axis. So this area which you draw from the curve till the x-axis, now it is in the shape of rectangle, isn't it? So what is this area? It is definitely the half of the rectangle. So tell me guys, what is this area? Half into base into height, right? This is what you say.
Yes, sir.
So base into height is what basically what? The full rectangle, right? And then you make it half to make it a triangle area. So again, if I call this as delta x and if I call this as delta y, the height. So tell me guys, what is the area? So the way of saying it is half of the area that the rectangle of length delta x and delta y would have formed. This is what you're communicating to the world. You're not saying half AB, you're saying it is equal to half of what we know. Understood? And so if I draw another side, the other side is also having a separate rectangle, right? So in a way, if you take half from the left rectangle, half from the right rectangle, so if I say this is a delta x and this is some value, let's say, okay, let's call this is delta x. And if I just call it as some value L1, L2. So this area, the left area is how much? Half of this, half L1 delta y. The right area is how much? Half L2 delta y, isn't it? And that is why if you add the value, you get half into base into height, the total base. But everything we are able to derive from the only one formula, no? Rectangle, isn't it? So no matter how I draw it, if I draw something like this triangle, and you may say that, okay, so now this is not rectangle, this cannot be coming from rectangle. Can we say like this? It is a big rectangle. And it is minus. Do you realize that there is a difference here, right? If I choose this length as L, and this part which is not mentioned, this is L dash. The height is H. What is the area of this rectangle? So first you find the full rectangle area. So what is the full rectangle area? L plus L dash into H. And if I make it half, what I'll get is, look this carefully. I'm going to get this area, right? Do you realize this area? Everyone?
Yes, sir.
And is it a half L plus L dash into H? Is it okay? Tell me, guys.
Yes, sir.
Yes,
Is
sir.
this part clear? Now, what is missing here? That in the bigger area, this part is missing. So we need to remove this area, isn't it? Which itself is half of this rectangle. Minus, what is the area of this rectangle? Half of the small rectangle is how much? Tell me.
L dash into H.
Excellent. And if you simplify, what you get? Again, half LH. So this is the base, only this much base. And the height means the perpendicular to the base. You extend the line, you draw a perpendicular, this is the height. Do you realize that every formula comes from the rectangle? Or how many of you realize? Look at the cylinder. White cylinder is so famous because a cylinder is a wrapped rectangle, isn't it? You cut a cylinder and open it. How it look like? If I cut like this from one of the edge, and if I put flat, it will look like a rectangle. Yes or no?
Yes.
Yes, sir.
And what is the length of rectangle? The perimeter of the circle? Yes or no? So the length will be the perimeter, the base perimeter. Do you realize this? The base perimeter is the length. Do you
Yes, sir.
realize this? So if I call this radius as R, the height is H, this is H, and this is 2 pi R. What is the area of rectangle? Area of rectangle is how much? Tell me, guys.
2 pi H.
Which itself is the curved surface of cylinder, isn't it? Do you realize this?
Yes, sir.
Hopefully, one fine day you will realize. So we'll see this chapter. I mean, the integration chapter is very, very interesting chapter. We are going to see two things in this chapter, particularly the idea of area and the idea of volume, because that is the crucial to the rest of physics. in physics, after the chapter of and in fact I would say after the laws of motion part is over, from work energy chapter onwards, the entire physics is all about area and volume. So you will see that we have to cut elementary, write the volume, write the area, and then solve the question. So it is very, very imperative or important, you can say, to understand what is the real meaning of area. We don't have any other area than rectangle. So we have to develop a perspective in which we can see that rectangle which is invisible to us. We have to create that rectangle in our brain somehow. So that is a practice. I mean, we all develop. And fortunately, I developed as a student. And the benefit was that I was able to derive equation or formula much faster than my teacher. So my teacher used to struggle on a board, and meanwhile I should derive in no time. So that is why, I mean, it just happened to me. I mean, I was not knowing this is all I'm trying to understand, but I just realized two things: the rectangle, and I realized this intuitively. I mean, how area and volumes are written typically. So that imagination helped me tremendously in mastering the derivation in physics. So if you want to master the derivation part in physics, if you want to create a formula, a new formula from a new situation, then this idea will be your weapon. I mean, if you really understand volume, if you really understand area, the two things are more than sufficient to master 50% of physics. I'm saying without knowing much concept. Even if you don't know a lot of concept, you can command 50% just with the idea of area and volume. And I would say the rest 50% depends on the fundamental definitions. I mean, some very deep concept, the theoretical ideas. So the theoretical ideas are something different, which is again part of physics, of course, but it is also true that the mathematical derivations are even a bigger part of physics. Okay. And derivation is only possible if you really understand the two concepts of area and volume. So I hope the area part is clear to all of you. Okay.
Yes, sir.
Now every diagram cannot be rectangle, isn't it? Or every diagram cannot be triangle. So what we can do if we fail to see either a rectangle or a triangle, how we are going to attain or get the answer in such scenario? So here comes the idea of integration. So the idea of integration is very simple. You have any random curve. Now it is really bad curve. And if you look below or beneath this curve, the area neither appearing as a rectangle nor as a triangle, isn't it? Can we say? So do you see this area as a rectangle or triangle or nothing? So are you able to see any rectangle here or any triangle here? Anyone? Yes or no? Yes or no? Tell me. Can you see rectangle, guys? Can you see triangle? Hello, hello, hello. Am I audible?
Yes, sir.
Yes, sir.
So I'm asking something. Why don't you reply? What I'm asking?
Sir, because it's an irregular.
It is irregular shape, so we don't have, na? That's simple. So can we apply the formula of rectangle?
No, sir.
No. So when this happens, then what will come to your rescue? The idea of elementary behavior. What is that behavior? Let's say someone is at X. Let's say someone is at X So what I'll do is I'll draw a line, vertical line, and this line will join the graph to the base. And by definition, again, these are definitions of function. The function represents the y value, and the y value represents the height in a way, isn't it? So what y equals to fx represents the height of the graph at that location x, isn't it? So graphically, the height is clear. The function itself is height. The y is the height of the graph. Is this clear? So what we do next is, we are having a smart move. What we do next is, we move very close to this line and we cut another line. How close? Technically, almost at zero separation. And if I draw, will you agree that this is like a rectangle? Yes or no?
Yes, sir.
And if this is a rectangle, if the first red line is at x and the next line is x plus dx away, and dx is really small, what is the area of this thinnest possible rectangle in the inverse? What is this area? It will follow the area of rectangle idea, isn't it? Agree, yes or no? Do you agree?
Yes, sir.
And if that is the case, what is this area? Can you express the area in terms of y and x? I mean dx, whatever.
Dx into y.
Very good. So this area is a very small area, so we can call this area as elementary behavior area, or we can call it dA. And dA turns out to be the length into the width. Is this clear? Yes or no? Is this clear?
Yes, sir.
Yes,
So
sir.
the function y, see what is coming here? Some function y, and the dx is saying that the y depends on x. Okay. So y dx is basically what we do geometrically. We are trying to find the area. The physical meaning may be anything, but geometrically it is giving you area of the thinnest possible rectangle. Okay, let me zoom it to see something more deeper. Okay, so let's try to see something more deeper. If I zoom this portion, if you zoom it, what you will see is a slant line and two vertical lines. Correct? So the reality is, it is not exactly a rectangle, but it is more of a trapezium, isn't it? Yes or no?
Yes, sir.
So if you zoom it, you can see it's like a trapezium. It's a slightly tilted, but the extra area we are calculating, let's say if I'm taking the reality is, we are calculating this much area which is below. If I take the height as the initial value, because if I choose the height at x, so the height will be fx. how much area we are missing in this calculation. So definitely we are not getting all area, right? We are missing some part. And do you realize the missing part? Do you realize the missing part? The missing part is a small triangle, isn't it? So the missing part is a small triangle. Is this clear? Yes or no?
Yes, sir.
Yes, sir.
But how we can minimize the loss? Of course, there's a loss. So if you take a bigger step, then the loss will be prominent. So if I take an interval big values x and then x plus delta x, then x plus 2 delta x, then x plus 3 delta x, then x plus 4 delta x, and so on. A bigger interval method, which we generally do in the math lab. If you also heard, I mean, you might have heard about the math lab. Okay. So in some school they do this integration by plotting the graph, and you actually calculate using the ruler, and then you also try to understand the error part which you are missing, and then you find the net area. So no matter what shape is given to you, we can approximately find the area, if not exactly. So what integration is doing is it is trying to minimize this missing part. And how to minimize this, guys? Tell me. And also you can see one thing clearly. I am taking the height as per the x value, not for the x plus delta x value. Now imagine if I choose the x plus delta x value as a height value. So if I choose this as my height, what will happen if I choose this as fx plus delta x? If you choose the right one as the height, you will end up getting extra area, isn't it? Yes or no, guys? Tell me.
Yes, sir.
So the actual area will be less than or in between these two extremes. Yes or no? The actual area will be the bigger area. So we can say the actual area is more than fx delta x, but less than, let's call delta, but less than what? Isn't it? Hello, hello, hello.
Yes, sir.
Are you able to understand this part? That area is more than the lower limit height area. If I choose the lower end as the height, and the answer is going to be less than if I choose the right end as the height. It is somewhere between. Okay. So what we do is if delta x tends to 0, so just write here limit delta x tends to 0. But if delta x tends to 0, if it is really small, the LHS becomes fx dx. Even the RHS also becomes fx dx because delta x is tends to 0, right? So compared to x, delta x is so small that we can ignore. A function which is more than this and less than this, what does it mean? The dA must be. So a number which is more than 1 and less than 1, it means it is wrong. It must be the number itself. We generally put in equality. So the dA we can write as only fx dx. And from here you can remember the fx always we take at the x position and we multiply with the dx. So when the dx will tend to 0, the missing area, whether it is less or more, the error will decrease, yes or no? And in the limiting case, can we say we are going to get almost correct value? Yes or no?
Yes, sir.
Are you getting the idea what I'm saying? I'm saying that when you multiply fx with dx, then the error is really small. It is almost zero error, which means you're going to get almost entire area. You're not going to miss a lot. So we miss the value only when the gap is more. So if I cut a strip, we call it this as elementary strip. This is called strip, but this is called elementary strip. And the problem is strip is not good. It will give a lot of error. But elementary strips are good because it will give you almost no error. So to get the entire area beginning from x1 till x2, what you have to do? You have to add all such values, such thin strip, right? So the total area is how much? Tell me guys, total area between x1 and x2, what we can write? So we have to add, so what you write is, so the total area is you add or you sum. What you need to sum? Fx dx from where to where? From x1 to x2.
X2.
Now the sum, we remove the and we keep the s. So what happens? We keep the s and it's understood, and we write fx dx, but this is not a convenient way of writing. So what we do is we stretch this s to make it bigger, and it looks like this. So basically this is the s symbol. So you add all fx dx, and then how to communicate this information x1 and x2. So you begin at x1 and end at x2, and what we call the x1 is called the lower limit and x2 is called upper limit. So this entire the mathematical symbolic presentation is a way to communicate what we are trying to achieve. So what is we are trying to achieve here? What is the communication? Can you read this entire symbolic notation and make a sense out of it? So fx is the height, dx is the width, x1 is like from where to where. And what is the geometrical interpretation? It is the area under the curve. What we call area under the curve. Which curve? Y equals to fx. And what is the meaning of limit? So of course a curve will have infinite area, because if the curve is spread up to infinity, we will have infinite area. So we are only concerned with some finite x coordinate, and we are only looking for that area. Is this clear part? This part is clear, guys? Tell me. Do you realize the meaning of area? Yes or no?
Yes, sir.
Everyone?
Yes, sir.
Yes, sir.
Is it very difficult? Yeah, it is difficult. So the integration symbol is basically summation symbol for summation. Okay. And fx dx is the rectangle. The other way of looking at it is this. So just like dy by dx is the slope of tangent and d by dx is operator similar to that idea in integration also. We write y dx, and dx is called integrator. This is called integrand. Okay. And the meaning is the integrator will decide which kind of object it can integrate. So this is only possible. This is integrable. We call it integrable. This is integrable only when the y is a function of x. Let's say, who was the national integrator of India? National integrator. Anyone knows? Sardar Vallabhbhai Patel. I hope you have heard this name in history books. So what he did actually, he took all the provinces and a small kingdom and combined into a state, which we know today, Maharashtra, Andhra, and so on. So the idea of state was not there before the independence. Rather, we had the provinces or the influence area of a king. And he said, no, you cannot be king anymore because now we are into democracy. So you have to become part of a state. And therefore, the idea of state came into picture. So Vallabhbhai Patel is the integrator for Indian provinces and all. Okay. So dx is playing the role of the Patel, and Patel can only integrate if you belong to India. Patel couldn't have integrated the Japanese or Europeans. And of course, so in a symbolic meaning, the dx will tell you that who all can be integrated or who all I can add them together. So the answer is anyone who depends on me, that is x. So if I have only dx, if I add dx and dx and dx, what will happen? If I just want to add dx, so basically, if you see nothing here, you may get confused that what I can integrate. The answer is, don't worry. Here, if nothing is there, then 1 is there. Okay. So the function here is y equals to 1. So for this integration, I'll say here, what is y here? If you see nothing, then you can assume y equals to 1. Let's go back to graph. How the graph of y equals to 1 will look like, guys? Tell me. How the graph of y equals to 1 will look like? A line which is parallel to the x-axis, yes or no? And the height of this line will be 1. Yes or no? Tell me.
Yes, sir.
So if I find the area up to x, let's say I find the area from 0 to x, how much I will get? Tell me. What is the area of this rectangle? Area of this rectangle is how much?
X.
1 into x, which is x. Therefore, the integration of dx will give you x plus some number. We write it c, we'll come to that. So this is the difficult part for most of us. When I write only dx, inherently 1 is present, and therefore 1 dx will give you x. And why we write plus c, I'll come to that later on. Okay. So I hope this is clear, guys. Is this clear?
Yes, sir.
See, when we don't mention from where to where, when we don't mention limit of integration, we add C. When we know from where to where, we don't add C. So this is called indefinite. We are not sure from where to where. Indefinite integration. So when you don't know from where to where, you write plus C as a symbolic meaning to the world that, okay, I don't know from where to where. If you fail to write C, your answer will be deemed as incorrect in the world of integration. So plus C is mandatory, but we'll come to that if it is not indefinite. If it is definite, the rule is different. So for definite integration, the rule is simple. So if you integrate some function fx, let's say y, if the integrator is dx, and if the limit is x1 and x2, so after integration you will get something. Let's call something as capital Fx, and it's logical to use capital because when you add a small thing, you get a bigger thing. That's also a notational meaning to it. So a small fx dx after addition will become something big fx, and the limit is given to us from x1 to x2. So what we do is, the rule is simple. You find the answer from origin to x1. So let's say if you think that if you want to know the answer, try to understand this, what I'm trying to do here. Imagine if someone is willing to get this area, which is from x1 to x2. So can we say the area from x1 to x2 is equals to area from origin to x2 minus area from origin to x1? Isn't it? If I subtract the full area minus this area, will I get the area between? Yes or no? So big area minus small area is equal to the area which I need, the desirable area. Understood? So the same logic goes here. When you integrate from 0 to x2, you get this area, and when you integrate from 0 to x1, you get this area, and then you subtract to get the area between x1 and x2. That is how we express the answer. And here we don't write C because we are doing the definite integration. So this is called, this way of writing is called definite integration. So the idea is clear, definite and indefinite. Okay. So in general, for indefinite, there are many layers to this, and I'll teach you something even more deeper. So first you understand the basic, then we'll go deeper. And so we write fx dx. If I don't put limit, what I write is fx plus c. And c means any number, any constant. It doesn't need not to be any one value. It is called constant of integration. So I hope this is clear so far. Okay, so we'll do the practice of numerical problem in the next lecture. And your homework is just to revise and finish the remaining problem of the up to dy by dx as rate measurer. And if any doubt arises, you can ask in the next lecture. Okay. But keep on practicing the maxima minima rate measurer. Your physics is happening. You might be thinking that, okay, I haven't learned any physics, but the fact is you have no realization that you have finished almost 30 to 40% of physics already without knowing physics. That is a beauty, because what really matters is this calculation. So once I keep on adding the topic, you can do the manipulation with ease. You will realize that, okay, I know everything actually. Okay, so it will come to you later on. You will come to the realization part. But right now, I'll only suggest that keep on revising. Don't doubt my intention. You're going to become extraordinary in physics. I can guarantee if you just stick to my ways, my rules, and my instructions. Okay. So revise, revise, practice, practice, solve and solve. Good night. Take care. See you in the next lecture.
Yes, thank you.
Thank you, sir.
Bye, guys.